Good morning, students. I'm your Nagini ma'am. Today I'm going to discuss about the packing efficiency. How to find the packing efficiency in simple cubic unit cell. Okay, students. So first of all, what is the packing efficiency and how to find the packing efficiency in simple cubic unit cell? We will discuss. Okay, students. Now I'm taking the simple cubic unit cell. So first of all, I will discuss packing efficiency definition, students. Packing efficiency. What is packing efficiency, students? The percentage of the total space occupied by the particles is called packing efficiency. The percentage of the total space. The percentage of the total space. The percentage of the total space occupied by the particles. Clear? So the percentage of the total space occupied by the particles is called packing efficiency. Clear? So how much percentage of the space occupied by the particles in the unit cell is nothing but packing efficiency, students. Now I'm going to calculate the packing efficiency in simple cubic unit cell. Okay, students. So first of all, I'm taking the simple cube. Cubic unit cell I'm taking, students, simple cube. So we know that what is the definition, students? Simple cubic unit cell or primitive cubic unit cell means it contains only corner particles, correct? So the total eight particles occupied at the eight corners. Clear? So that is the simple cubic unit cell, correct? What, students? SC means what? Only eight corner particles will be there. Eight corner particles. Clear? It contains only eight corner particles, students. It does not contain any body center, face center particles. Only it contains eight corner particles. Clear? So that's why that eight particles here, 1 2 3 4 5 6 7 8. Here I am taking the two particles, this one and this particle. These two particles are touches with one another, okay, now near to each other. So that's why these two particles I am taking, students. We know that the particle is considered as a sphere. So that's why this particle sphere, its shape is sphere, student. So I'm taking as this is the sphere, and this particle also I'm taking as a sphere. Clear this one? Okay, now from here to center to here, this distance is called radius, students. What is this one? Radius. And this also radius, r. Okay, this total is called, this from here to here, this is the edge length, correct? A is equal to what we can write? 2r. Clear, students? I am taking these two particles. These two particles are touches with one another. So we know that the particle is considered as a sphere. So that's why this particle sphere, this particle sphere I am taking, both are touches with one another. And from here to here distance is r. This is from here to here distance is r. Correct? That is nothing but atomic radius. So atomic size or atomic radius is nothing but it is the distance between the center of the nucleus and the outermost shell of an atom. Okay, now otherwise we can say that it is the half of the distance between the neighboring atoms. Okay, now so that is called atomic radius. Clear, students? What is atomic radius, students? Atomic radius. Atomic radius means it is the half of the distance. It is the half of the distance between the neighboring atoms, between the two neighboring atoms, students, between the two neighboring atoms. That is nothing but atomic radius. Otherwise we can say that it is the distance between the center of the nucleus and the outermost shell, valence shell of an atom. Clear, students? So that is nothing but atomic radius. It is the half of the distance between the two neighboring atoms also we can say. So this is the atomic radius, students. Now we have to find the radius value. R is equal to, we should find, students. So from here, from corner to this corner, edge length is equal to a is equal to what we can write, students? A is equal to r plus r, 2r kada. So what we can write, students? A is equal to First I am taking edge length. Let edge length is equal to small a. Okay, next radius. Radius is equal to small r, students. Then what we can write, students? A is equal to 2r kada. A is equal to r plus r. A is equal to 2r. That means r is equal to what we can write, students? A by 2. R is equal to a by 2 we can write. So this is the radius in simple cubic unit cell, students. This is the formula you have to remember, students. Important formula. Okay, after that we have to calculate the packing efficiency. Before going to that packing efficiency, see, students, here the volume of the unit cell. This is the unit cell. Unit cell is which shape, students? It is a cubic unit cell kada. So that's why it is a cubic unit cell na. So that's why its shape is what is its volume, students? Volume of the cube is a cube kada. So that's why what is the volume of the unit cell, students? First one, volume of the unit cell is equal to a cube. Volume of the unit cell is equal to a cube. Because why unit cell is equal to a cube we are taking, students? Because unit cell shape is cube. So that's the volume of the cube, because unit cell is nothing but cube here. Volume of the cube is equal to a cube. Now I am taking the volume of the particle, students. The volume of one particle. Particle is which shape, students? This is sphere kada. So that's why volume of the sphere is equal to 4/3 pi cube. Clear? So that's why what I am taking, volume of the particle is equal to 4/3 pi r cube. Clear, students? Here particle shape is sphere na, so that's why I am taking as 4/3 pi r cube. Clear? This is the volume of the particle, right? Next, the number of particles per unit cell. In the simple cubic unit cell, students, what is the z value, students? How to find z value? In simple cubic unit cell, students, only 8 corner particles will be there. So 8 corners. So yeah, into each corner particle contribution is how much, students? 1 by 8 kada. So that's why 8 ones are 8. How much? Z is equal to 1. That means the number of particles per unit cell is equal to 1. Okay, write that point, students. The number of particles per unit cell is equal to Z is equal to 1, students. Z is equal to 1. Next, the volume occupied by the particles. Volume we have to take, students. The volume of the particle is 4/3 pi cube. The total the number of particles per unit cell, Z is equal to 1 kada. Z is equal to 1 na. So total volume occupied by the particle is equal to how much, students? The total volume. The total volume occupied by the particles is equal to how much, students? 1 into 4/3 pi cube. That is Z into 4 by 3 pi r cube. 1 into 4 by 3 pi r cube, students. Okay now. So here total particles are 1 in SC, simple cubic unit cell, and volume of the particle is 4/3 pi cube. Total volume, how to find, students? Z into 4/3 pi cube. This is the total volume, students. Now packing efficiency we have to find. How to find, see, students? Packing efficiency. Packing efficiency is equal to formula. Packing efficiency is equal to total volume occupied by the particles divided by volume of the unit cell. Volume of the unit cell, students, into 100%. This is the packing efficiency formula, students. So by using this formula we can calculate the packing efficiency. Okay, so total volume occupied by the particles, how much, students? Here how much? 1 into 4/3 pi cube kada. 1 into 4/3 pi cube. So that value take here, 1 into 4/3 pi cube. So 4 by 3 pi r cube divided by volume of the unit cell. What is the volume of the unit cell, students? A cube na. So that's why I am taking as volume of the unit cell is how much, students? A cube. Okay, into 100%. Clear this, students? okay, into 100%. Now this is the packing efficiency, students. So packing efficiency is equal to 4 by 3 pi. R value how much, students? Here R is equal to how much? Radius. R is equal to a by 2 kada. R is equal to a by 2. So R value here substitute, students. R is equal to a by 2. So a by 2 whole cube, R cube na, so that's a by 2 whole cube divided by a cube into 100%. Clear this one? Into 100%. Then packing efficiency is equal to 4 pi a cube, as it is, take, students. Here in the denominator 3 is there, here 2 cube is there. 3 into 2 cube means 8. Here already the denominator a cube is there, into 100%. Now this a cube will get cancelled, students. And here 4 how many times? 2 times. Then pi by 6. 3 2s are how much, students? 3 2s are 6 into 100%. Clear? This value, pi value 3.14 into 100 by 6 percentage. Then you will get the answer 52.4 percentage. This is the packing efficiency, students. How much? Packing efficiency. Clear this one? This is the packing efficiency, students. 52.4 percentage. That means the particles, how much space is occupied, students, in the unit cell? 52.4 percentage space is occupied. Okay, now occupied. What is the empty space? What is the remaining space, students? How to find it? Empty space. See, students, empty space, how to find it? See, empty space, that means we have to subtract, students. Total 100 kada, 100 minus 52.4. okay, then you will get the empty space, students. 100 minus 52 point, 100 minus 52.4. okay, then how much you will get? How much, students? 52.4, 47.6. Clear? So this is the 47.6 is the empty space. That means this much space is empty and 52.4% is space is occupied by the particle, students. This is the packing efficiency in the simple cubic unit cell. Clear this, students? Once again, see, students, simple cubic unit cell. What is the packing efficiency? The percentage of the total space occupied by the particle, students. Simple cube, 8 corner particles will be there in the simple cube. Atomic radius I am taking. What is atomic radius? It is the half of the distance between the two neighboring atoms. Let the edge length is equal to a, radius is equal to r. Then edge length from corner to corner, length, edge length is equal to a is equal to r plus r, 2r. Then r is equal to a by 2, students. And in the simple cubic unit cell, z value 1, because 8 corner particles and each particle contribution is 1 by 8 now, so z value 1. Volume of the unit cell a cube, the volume of the particle, number of particles. Clear the, students? Afterwards calculated packing efficiency. okay now? Thank you, students. I hope you like this video. Please like, share, comment and subscribe my channel, students. Thank you, students.